Welcome back to our channel where we simplify cloud concepts for you. Today we'll discuss about Azure Virtual Network, and for this we have prepared 20 question set with few basic and few advanced question set. So let's get started. So here is first question. What is an Azure Virtual Network? VNet? So Azure Virtual Network is like your own private network inside the Azure cloud, and it works just like the network you use at your home or office where computers can connect and talk to each other. With a VNet, we can connect Azure resources like virtual machines, databases, and apps so they can securely talk to each other. Also, we can control the traffic using firewalls, rules, and security groups. We can also connect to our on-premises network using VPN or ExpressRoute, so our cloud and office systems work together. We can also keep our data private and safe because the VNet is isolated from other networks in Azure. Hope you understand. Now let's discuss about second question. Can two VNets in different regions communicate? Yes, it is possible. Two virtual networks that are in different Azure regions can be connected using global VNet peering. This allows the resources like virtual machines in one VNet to talk to resources in another VNet, even if they are in different parts of the world. For example, if one VNet is in central India and the other is in East US, they can still communicate with each other if you pair them globally. Once global VNet peering is set up, the communication between the VNets is secure and fast. Also, the data travels through the Microsoft backbone network, not the public internet. So it's more private and reliable, and you don't need a VPN or any gateway for this connection. Next question is, can two subnets in the same VNet have overlapping IP ranges? No, two subnets in the same virtual network cannot have overlapping IP ranges. Each subnet in a VNet must have its own unique IP address range, which should not overlap with any other subnet in that VNet. This is because Azure uses these ranges to route network traffic correctly. If two subnets have overlapping IP ranges, it will create confusion in routing, and Azure will not allow you to create such subnets. For example, if subnet A has IP range 10.0.0.0/24, then subnet B cannot have 10.0.0.0/25 or 10.0.0.128/25 because they fall inside the same range. So, always make sure that each subnet has a different and non-overlapping IP range. Next question is, what is the difference between ASG and NSG? ASG means Application Security Group and NSG means Network Security Group. Both are used in Azure to control the traffic going in and out of virtual machines, but they work differently. NSG is like a security guard that holds all the rules to allow or block traffic based on IP address, port number, or protocol, and it can be applied to a subnet or directly to a VM's network interface. On the other hand, ASG is more like a name tag or group for similar VMs. So instead of using IP addresses in NSG rules, we can use ASG names to make rule management easier, especially when VMs are added or removed. So the main difference is that NSG is where we define the security rules, and ASG is what we use inside those rules to group and manage VMs more simply. For example, you can use an NSG to block internet access to a VM or allow only port 80. For example, you can create one ASG for web servers and allow only app servers to talk to it without worrying about the exact IPs. NSG is the security rule container, the place where rules live. ASG is a label for VMs used inside NSG rules to make things easier. Next question is, how to deny internet access from a subnet using NSG, Network Security Group? To block internet access from a subnet in Azure, you can use a Network Security Group NSG by adding a rule that denies outbound access to the internet. Step-by-step explanation. Go to Azure portal and open the NSG that is attached to your subnet. In the Outbound Security Rules section, click on Add to create a new rule with below. Put name, Deny Internet Outbound. Set priority, any number lower than 65,000. Example, 100 or 200. Direction should be outbound. Protocol, any. Source, any. Source port ranges, asterisk. Destination, internet. Destination port ranges, asterisk. Action, deny. Click add to save the rule. So what it will do? This rule will block all outbound traffic from that subnet to the internet. Any VMs or resources in that subnet won't be able to browse the internet or connect to external services. Next question is, what is VNet peering? VNet peering is a feature in Azure that allows to virtual networks to connect with each other, so that the resources like virtual machines, databases inside those VNets can talk to each other directly using private IP addresses. So, it is like creating a friendship between two separate virtual networks. They stay separate, but they can share data and services safely and quickly. For example, if you have one VNet for your application and another VNet for your database, you can peer them so your app can access the database without going through the internet. This makes communication faster, more secure, and cost-effective. Please make note that there are two types of peering. Intra-region peering, when both VNets are in the same Azure region. Global peering, when VNets are in different Azure regions. Also, VNet peering is non-transitive, meaning if VNet A is connected to VNet B and VNet B is connected to VNet C, then A cannot directly talk to C unless A is also paired with C. Next question is, what is a private endpoint? A private endpoint in Azure is a way to connect your Azure service privately using your own virtual network. Normally, when you access an Azure service, your request goes through the public internet. But with a private endpoint, Azure gives a private IP address from your VNet to the service. This means your traffic stays within the Microsoft network. It doesn't go over the public internet. It is more secure because only your network can access the service. It helps follow company security policies or government rules about data privacy. For example, if your company has a storage account with sensitive data, you can use a private endpoint so only people inside your office network or Azure VNet can access it, and not anyone on the internet. Now next question is, how is a service endpoint different from a private endpoint? A service endpoint and a private endpoint are two ways to connect to Azure services securely, but they work in different ways. Service endpoint. It allows resources in your virtual network to connect to Azure services like storage account, SQL database, etc. over the Azure backbone network, not the public internet. It keeps the service public, but allows access only from your VNet. The traffic flows through your VNet's subnet, but the Azure service itself still has a public IP address. It's easy to set up and doesn't need extra components. Example, you allow only your VNet to access a storage account, but the storage account still has a public endpoint. Private endpoint. A private endpoint is a private IP in your VNet that represents an Azure service. It brings the Azure service inside your VNet, so the service can be accessed using a private IP like an internal resource. The Azure service no longer needs a public IP for access. It is more secure because all traffic stays within your private network. Example, you access a storage account using a private IP like 10.0.0.5 from your VNet, no internet involved at all. Next question is, what is ExpressRoute? ExpressRoute is a service in Microsoft Azure that allows you to create a private and dedicated connection between your on-premises network, like your Office data center, and the Azure cloud. Unlike normal internet connections, ExpressRoute does not use the public internet. It provides a more secure, reliable, and faster way to connect to Azure. This is very helpful for companies that deal with sensitive data or need high-speed connections without any interruptions. For example, banks, hospitals, or large IT companies often use ExpressRoute to safely move data between their servers and Azure. Next question is, how to force all traffic from a subnet through a firewall? To make sure that all network traffic from a subnet goes through a firewall, you need to use user-defined routes, UDRs, in Azure. This is called forced tunneling. Here is how you can do it step by step. Create a route table. In the Azure portal, create a new route table. This will be used to define custom routes for the subnet. Add a custom route. In the route table, add a new route with address prefix 0.0.0.0/0. This means all traffic. Next hop type, select virtual appliance. Next hop address, give the private IP address of the firewall, for example, Azure Firewall or a third-party NVA. Associate the route table with the subnet. Now, link this route table to the subnet from where you want to force the traffic through the firewall. Make sure the firewall is configured properly. The firewall should have rules to allow or deny traffic based on your requirements. It should also be able to forward the traffic to the internet or other networks if needed. Disable bypass options if needed. Some Azure services bypass the firewall by default. You may need to check and update the settings if you want full control. In simple terms, you are telling Azure, from this subnet, send all traffic to the firewall first, and then let the firewall decide where it should go. This helps in monitoring, controlling, and securing the traffic better. Next question is, what tool helps troubleshoot VNet connectivity? To troubleshoot virtual network connectivity issues in Azure, Network Watcher is the main tool used. It is a built-in service provided by Azure that helps check and monitor the network connections between your virtual machines, subnets, and other Azure resources. One of the most useful features inside Network Watcher is the Connection Troubleshoot tool. It lets you test whether one VM can connect to another resource like another VM, a load balancer, or even an external website. It shows you whether the connection is successful, blocked, or failed, and also tells you the reason, like a misconfigured network security group, NSG, or route table issue. Another useful feature is IP Flow Verify, which checks whether traffic is allowed or blocked based on your firewall or NSG rules. So in simple words, Azure Network Watcher is like a doctor for your Azure network. It helps find out what is blocking the connection and where the problem is happening. Next question is, what is subnet delegation? Subnet delegation means giving special permission to a specific Azure service to use a subnet inside a virtual network, VNet. In Azure, when you create a subnet, you can delegate it to a particular service like Azure App Service, Azure SQL, Azure Container Instances, etc. This tells Azure that the subnet is dedicated to that service and allows the service to automatically create and manage network settings like network interfaces inside that subnet. It helps in better integration and control between the Azure service and the virtual network. Example, if you want to run Azure App Service environment, it needs a subnet with delegation. So, you delegate that subnet to Microsoft.web hosting environments. After that, only ASE can use and control that subnet. In simple words, think of subnet delegation like reserving a room only for one guest, Azure service. You are telling Azure, this subnet is only for this service. Let it manage everything inside. Next question is, can I resize a subnet? Yes, you can resize a subnet in Azure. But there are some important points to remember. You can only increase the size of a subnet, means you can add more IP addresses by changing the subnet mask, for example, from 26 to 24. This gives you more room for adding virtual machines or other resources. You cannot reduce, shrink the subnet size because Azure does not allow you to remove IP addresses that might already be in use or reserved. Make sure the IP range you want to add does not overlap with any other existing subnets in the same virtual network. Resizing is possible only if there are no IP conflicts and if there is enough address space available in the virtual network. For example, suppose you created a subnet with the address range 10.0.0.0/26, which supports 64 IP addresses. Later you realize you need more. You can resize it to 10.0.0.0/24, which supports 256 IP addresses if that range is free in your VNet. Next question is, an NSG is applied to both a subnet and a NIC. Which takes precedence if rules conflict? When a network security group is applied to both a subnet and a network interface card, NIC, both NSGs are evaluated together. Azure checks both sets of rules from the subnet and the NIC. But if there's a conflict between the two, like the subnet NSG allows traffic, but the NIC NSG denies it, the more restrictive rule wins. So in simple words, deny always wins over allow. It doesn't matter whether the rule is from the subnet or NIC. Azure looks at all the rules, and if any one of them says deny, then the traffic is blocked. Example, subnet NSG allows port 22. NIC NSG denies port 22. Result, SSH will be denied because deny takes priority. Next question is, what is the role of Azure's 168.63.129.16 IP address in VNets? In every Azure virtual network, the IP address 168.63.129.16 is a special system-reserved IP that plays a very important role in the background. It is used by Azure itself to provide key services to your virtual machines and other resources inside the VNet. You don't need to assign this IP or manage it. Azure uses it automatically. Main uses of 168.63.129.16 DNS communication for Azure provided DNS. If your VM is using Azure's default DNS, it talks to this IP to resolve domain names like converting www.google.com to an IP address. Health probes for load balancers. Azure Load Balancer sends health probe signals from this IP to check if your VMs are healthy and can receive traffic. VM Agent Communication. Azure uses this IP for VM Guest Agent to talk to the Azure platform for tasks like getting extensions, resetting passwords, and enabling diagnostics. Time Sync, NTP. VMs use this IP for time synchronization to keep their clocks accurate. Azure Monitoring and Diagnostics. Services like Azure Monitor and Boot Diagnostics also use this IP to collect and send data. Important points. It is not a public IP, but it is globally available in all Azure regions. You should not block this IP in your network security group or firewall, otherwise many Azure platform features may not work correctly. Next question is, how do you monitor traffic in and out of a VNet? To monitor the traffic going in and out of an Azure virtual network, you can use Network Watcher. It is a built-in Azure tool that helps track and analyze the traffic flowing through your network. Here are the main ways to monitor VNet traffic. NSG flow logs. These logs record all the traffic that goes through a network security group, which is like a firewall for your subnets or network interfaces. You can enable NSG flow logs using Network Watcher. These logs show you the source and destination IP addresses, ports, protocol used, whether the traffic was allowed or denied, and more. Logs are stored in a storage account and can be viewed using tools like Azure Monitor, Traffic Analytics, or even Power BI. Traffic Analytics. Once you have NSG flow logs enabled, you can use Traffic Analytics to get visual reports. It gives you a clear picture of which resources are sending or receiving most traffic, any suspicious activities, or common communication patterns. Connection Monitor. This feature checks the connectivity between different Azure resources or between Azure and external endpoints like on-premises or internet. It helps in identifying latency issues, packet loss, or connection failures. Packet Capture. For deeper inspection, you can use Packet Capture to collect and analyze raw traffic data between VMs. This is useful for advanced troubleshooting when you want to see the actual network packets. In simple words, Azure provides tools like Network Watcher, NSG flow logs, and traffic analytics to help you see what traffic is coming into or going out of your network. These tools help you understand and troubleshoot your VNet traffic easily. Next question is, can you use a single VNet for multiple UX clusters with different subnets? What are the considerations? Yes, you can use a single virtual network, VNet, for multiple Azure Kubernetes service clusters, each using different subnets. But there are some important considerations to keep in mind. Yes, it is possible to use one VNet for multiple UX clusters by giving each cluster its own separate subnet inside that VNet. This helps when you want to manage everything in one network and make communication between clusters easy. Key considerations. Separate subnets for each UX cluster. Each UX cluster must use a different subnet. You cannot share the same subnet between two UX clusters. Network security. Since all UX clusters are inside the same VNet, they can talk to each other unless blocked. Use network security groups, NSGs, to control access if needed. Next question is, you're using a hub-and-spoke architecture in Azure. How do you ensure spokes communicate only via the hub? In Azure, when we use a hub-and-spoke network architecture, we create one central hub virtual network, VNet, and connect other spoke VNets to it. The spokes are usually isolated from each other. To make sure spokes can talk to each other only through the hub and not directly to one another, we can follow these steps. Peering only with the hub. First, we set up VNet peering between each spoke and the hub. We do not peer spoke VNets directly with each other. This ensures that all traffic between spokes must go via the hub. Use remote gateways and allow gateway transit. While setting up peering, we enable the options use remote gateways on the spoke side and allow gateway transit on the hub side. This allows spokes to use the hub's gateway for communication with other networks or the internet. Use NSGs, network security groups. We apply NSG rules in the spoke VNets to allow traffic only to and from the hub VNet. We can also create deny rules to block direct traffic between spokes. Optional, use NVA or Azure Firewall in the hub. For better control and security, we can place a network virtual appliance or an Azure Firewall in the hub. This way, all traffic between spokes goes through this firewall, where we can inspect and control it. Avoid transitive peering. Azure VNet peering is not transitive by default. So even if spoke A is paired with the hub and spoke B is also paired with the hub, spoke A and B cannot directly communicate with each other unless we allow it through the hub. In simple words, we make sure that spoke networks are connected only to the hub and we block direct connection between spoke networks. This setup forces all communication to pass through the central hub where we can monitor or control the traffic. Next question is, how does an NSG differ from a firewall? An NSG, network security group, and a firewall both help to control the flow of network traffic in Azure, but they work in different ways and are used for different purposes. Scope and purpose. NSG is mainly used to control inbound and outbound traffic to Azure resources like virtual machines, VMs, subnets, etc. It works at layer 3 and layer 4, IP address and port level. Firewall, especially Azure Firewall, is a fully managed network security service that gives advanced protection. It works at layer 3 to layer 7, which means it can inspect application-level traffic such as HTTPS, rules and intelligence. NSG uses basic rules that allow or deny traffic based on IP address, port, and protocol. Firewall offers more intelligent rules like FQDN filtering, domain names, TLS inspection, threat intelligence filtering, and logging of all traffic. Use case examples. Use NSG when you just want to allow or block traffic between VMs, subnets, or from internet. Use firewall when you want to filter traffic based on domain names, protect from malicious websites, or need deep traffic inspection. Simple summary. Think of NSG like a security guard at a gate, checking ID and entry pass, IP, and port. And firewall is like a customs officer at the airport, checking your entire bag, asking questions, and blocking suspicious items. Now next and final question is, you have created VNet peering between two VNets, but VMs in both VNets cannot talk to each other. What are the possible reasons and how will you resolve them? Even though VNet peering is created, if VMs in both VNets cannot communicate, there could be several reasons. Let's go through them one by one and how to fix them. Missing allow forwarded traffic or allow gateway transit settings, optional based on use case. When you create peering, there are extra checkboxes like allow forwarded traffic, allow gateway transit if you're using VPN. If these are not enabled as per your network setup, traffic may not flow properly. Network Security Group (NSG) is blocking traffic. NSG is like a firewall. It may be stopping traffic between VMs. For example, port 3389 like RDP or 22 like SSH may be blocked from other VNet IP ranges. VM's firewall is blocking communication. The Windows or Linux firewall inside the VM might be blocking traffic. Wrong or missing routes. If custom routes, user-defined routes, UDR are used, and the next hop is incorrect, the traffic might not know where to go. Peering is not set up properly in both directions. VNet peering is usually two-way, meaning you need to create peering from VNet A to VNet B and again from VNet B to VNet A. I hope now you get good understanding for Azure VNet. If you found this video helpful, please like, share, and subscribe to the channel. Let us know in the comments if you want videos on more Azure related resources or topics. Thanks for watching and happy learning.